So I was talking about correlation analysis. So in our previous class, we said that correlation analysis is a bivariate analysis in such a way that we are trying to check a relationship between one column and another one. So for example, if you go to hospitals, we want to know, let's say, for example, whether your blood sugar affects your diabetes level, or for example, whether adult mortality affects the life expectancy. So basically, we have two columns here, and we are trying to check their relationship. And it's very important, as you're going to notice, that correlation is normally measured in a range between 0 and 1. Okay? Also, in this class, I think we mentioned that we have basically two types of correlation. So we have what we call a positive correlation. So I think I will share these notes so that we are together, because I want us to start from here. We had mentioned that we have, so allow me to share this one, the chart here. So we had mentioned that we have two types of correlation. So we have a positive correlation. And please, let's begin here. We say that with positive correlation, if you have a scenario whereby if we increase in one variable might lead to the increase in the other variable, we can definitely say that this is a positive correlation, and vice versa is also true. So for example, I was trying to give a realistic example. Let's say you're working with countries' export and the country's GDP. So these are two columns. So basically, it's actually said that if you increase the number of exports in your country, definitely the GDP ratio must also increase. So basically, you're saying that the exports and the GDP have a positive correlation. So alternatively, you can also say that if you reduce the number of exports, definitely your GDP ratio will also reduce. So that is also true. So increase in one variable leads to the increase in another variable, or decrease in one variable will also lead to decrease in another variable. So in our data set here, we saw that we are going to see that schooling and life expectancy have a positive correlation, such a way that if a government spend much on schooling, where people are being educated, so this means that people will actually have a decent life, because if you go to school, you have a good employment, you can get a good employment, you can have a good income. So basically, you have a decent life. And because of this, that reason, probably you might live longer than countries that have not invested much in schools. So you realize that people are doing manual labor, people are not living a decent lives, okay? So therefore, their life expectancy automatically becomes lower. So these are positive correlation, schooling and life expectancy. But we'll have to demonstrate that one here and see whether this is true, okay? So alternatively, I also mentioned about negative correlation. And we say that this is actually when one variable increases, the other one reduces. This is a very common feature, especially in machine learning, as we're going to see. I was giving like an example like dependency population. These are the population that is not working. If this is higher, you have a lot of people being unemployed in a country. They are what we call the dependent population. It should be dependent, not dependency, dependent. Dependent population. If you have countries' dependent population being higher, then it is obvious that the GDP will be lower, because these people are not contributing to the economy of this country. Therefore, the GDP is lower. So if you actually give a good example of a country like India, good example is a country like India, they have a very huge population, and you're going to realize that in some areas, they have a very huge dependent population. So therefore, in those areas, the GDP is lower, right? So similarly, I think we mentioned about adult mortality. and life expectancy. So if you increase adult mortality rate where people are dying, then definitely the life expectancy will reduce. So therefore, if you want this life expectancy to increase, then you'll actually have to reduce the adult mortality. I hope it had made sense to you about correlation analysis. It's very important. So we were now to do, how do you see this one in play? How do you visualize correlations? So we had mentioned there are two ways you can do this one. You can either decide to work with a scatter plot or heat maps. I think that is where we are. So we had mentioned that if you want to see how different variables are correlating to one another, either positively or negatively, you can work with these two plots. And that is what we want to do. So I hope you are ready. Let's proceed from there. I hope you're ready. So we can actually say that, let's start from here. So I think we are together now. We were using this as our guide notebook. That was the EDA. This was the distribution analysis. This was outlier detection. And now we were talking about scatter plots. Yeah. So let me give you good examples so that we can be able to read scatter plots. Right? We're able to read these scatter plots. So I wanted to show demonstrate this one very fast. So you've said that correlation analysis is bivariant. So therefore, we need, yes, Gloria, you're having a good question. How do you eliminate columns with too many null values? You're going to do this one after. Now, we want to talk about handling missing values. So you're going to do this one after this one. Okay, so let's finish with correlation analysis. Then now we start handling the missing values that we have. Let me go very fast. So we can say that from the SNS library, we want to get a scatter. It should be scatter plot, this one here. This scatter plot, you'll first give it the data as your variable data. So if you're working with DF, then you say that your data is DF. So remember, if you're working with the variable DF, then you can say that your data is DF. Then from there, because it is bivariant analysis, you need to have X. So for example, X, I want to see how adult mortality, yeah, this is good. Yes, I want to see how adult mortality correlates with life expectancy. Okay, so then I can even do that plt.show. So I want to see how the adult mortality correlates with the life expectancy. So let's see this one actually how it works. So if you read this one, this is actually what we call a scatter plot. So I want us to notice how this plot is. Let's begin here. If you see these plots going in this direction, I want us to see that graph. The plots are going in this direction. I hope you can see this one. This is what we call a negative correlation. A negative correlation. So a negative correlation shows that I think it should be the other way around. Let me just confirm here. Yeah, it's okay, it's okay, it's okay. So this one shows that if one column increases, the other one reduces. I hope you can see that if you increase if you increase the adult mortality, then as much as the adult mortality rate is increasing, the life expectancy is reducing. So this is what we call a negative correlation. Normally, they draw their graph in this manner here. Okay. So let me give you another example. I want to see how schooling affects your life expectancy. So if you run this one here, then you're going to notice that this one now, it's a positive correlation. So the graph is in this order in such a way that you're saying that if I invest much in schooling, you see when I'm investing at this point, my life expectancy is around here. If I invest at 10, my life expectancy is around 60. If I invest at 15, my life expectancy is around 70, and so on and so forth. Those are the two types of correlation that you can read using a scatter plot. So we have, when the graph is in this order, this is what we call the positive correlation. And then when you start in this other order, then that is the negative correlation. So to read this one clearly, you can even see that if I actually have a scatter plot, before I remove, I wanted you to try it here. Code. I want to try this one. Code. I'll share that piece of code there so you can try it. Yeah, then so then I want you to try now this one. How about if you have a scatter plot between schooling and schooling? Let's try to demonstrate this one. If I have a plot between schooling and schooling, what would happen? So if you read this one, then you'll actually draw a perfect line graph showing us that this is a perfect positive correlation of one in such a way that if this one is increasing, the other one is reducing. It's increasing as well. Okay. So this is actually now the positive correlation. So if you see a scatter plot that is trying to draw this kind of a scenario, then it's actually a positive correlation analysis that you're actually getting from the variables. So now I hope it makes sense. So now you might want to do for all the other columns. So now you might want to do for all the other columns. So if you run this one, this was actually it was very common in such a way that if I'm investing on schooling, I am increasing the life expectancy. So majority of the people's life expectancy is here. This is where they are scattered. If I invest on 15, their life expectancy is around 70. So it's a good way to show that if you invest on schooling, you also increase people's life expectancy. Yeah, so I wanted us to draw now for all the other graph. Okay, you're being told that SNS is not defined. So what I want you to do, I want you to go to runtime and run all. The reason for that one is that the SNS library, we have defined them here. So probably you've not run this plot, this code cell here. Make sure that you go to runtime and then run all the cells so that all these libraries will be defined. You'll be able to read your data, you're getting the columns and so on and so forth. Okay. So make sure you run all the code cells. So now I want us to do scatter plots for all the numerical columns. So that is actually the piece of code that you're seeing here. So that if I say for I in all these numerical columns, I can draw a scatter plot. I can just copy this one very fast. I can now paste it here. I hope it would make sense. I can actually have it right here. But for this one, I can actually replace it with this column so that it's actually easy to read. I can replace it with this one here. Because also correlation analysis is done on numerical columns only. So I can remove this one. Remove this one. I can just make it better that way. So for I want to select all the numerical columns. So this should be data, not df. Make sure it's data. Make sure it's data. And then X, so remember X, you are passing the schooling, so we'll be passing I. Y, we are going to want to see how all these other columns are correlating with our life expectancy. So if you run this piece of code, you'll actually draw all the scatter plots for the numerical columns. So we are going to see that some are positively correlated, like schooling. Other ones are negatively correlated. This is also positive correlated, such a way that If you have income composition of resources being increased, then the life expectancy is also being increased. So these are, well, I want to show you something here where we don't have a correlation, like this one, we don't have a correlation between life expectancy and diphtheria. So the scatters are all over. So there's no correlation. Even this one here, this is not a good significant correlation. Okay. Yeah. So this is a good one. BMI and life expectancy looks like there is a positive correlation. I don't know why, and so on and so forth. So I hope you have that one. Let me share that piece of code with you. We are going to refer to this one later as we are doing machine learning, especially for those people who will be doing data science. Data science, I'll share that one right there. So now from there, it's also good to visualize correlation with heat maps. It's also good to visualize correlation with heat maps. So I think that is what we have here. It's also good to visualize correlation with heat map. So, and this is actually how you do it. I'll show you. You want to visualize correlation with heat maps. So let's add a code cell here. Then you press it right here. So the first thing is that this should be data. Make sure this is data. Data. So we're using data as our column name store variable. We want to select all the data types that includes number, and then we perform a correlation. So if you run this piece of code, then this is actually the correlation. So we are going to see that there are those ones with positive correlation and those ones with negative correlation. So for example, a good one is something like adult mortality. I want us to see this one. Adult mortality and life expectancy have a negative correlation of 69%. This is a good one to show that if you increase adult mortality, life expectancy will reduce by almost 69%. Okay. Another one is this one here, 38, such a way that if we have more percentage expenditure, your life expectancy will increase by 38%. So there are those ones I hope you can see that are positive and those ones that are negative. I hope you can see them here. So a good one that I've noticed, and I don't know whether it's making sense. I don't know whether it's making sense. Maybe you can clarify with me. Is that those countries which partake alcohol, I'm sure these are the Western countries, somewhere like Ireland, their life expectancy is normally higher by 40%. So this is something unusual. I don't know whether you can agree with it, but that is actually the insight we are getting. Countries that have high alcohol, but taking a lot of, I don't know how to interpret this one, but the more you increase alcohol by 40%, we are also increasing life expectancy the same. Okay, so this is actually how you read correlation within your data. Basically, you're trying to see how each I think it's quality. Yeah, I think it's quality. Yeah, that is a good one. Thank you, John. Yes, that's a good one. Yes, if you go to countries that are taking good quality alcohol, yes, that's a good one. Their life expectancy is higher, yeah, than those people who are taking illicit ones. Yeah, that's a good observation. So this is actually how you read. There's one that is 50%. That was infant death and measles. Yeah. So in the code here, you can actually draw this one in a heat map so that you can visualize it very well. I hope you are noticing that it is not easy to read this one this way. So you can visualize it in a heat map. So to do this one, we can actually plot a figure using the matplotlib. Using the matplotlib, I think I can do it on a new code cell. I hope I've shared this one. Let me share this one with you. Using matplotlib, we can define the fig size that we need. We can define the fig size that we need. So basically, to define the fig size, let me just show you that one. You normally use matplotlib that we are calling PLT, because remember we said from matplotlib.pyplot we import matplotlib.pyplot as PLT. So from PLT we are getting the fig size, and then here we pass a tuple, and then we specify the dimension. So this one will give us a figure of x-axis being 15, y-axis being 15. We're going to see that one. Then inside that one, we can now generate a heat map where we pass this correlation. Let me first remove this one. Okay, let me do it easier for you to understand. So I'll show you how to do a heat map. Yeah, sorry for that one. So I wanted to show you how to draw this one better. So normally to draw a heat map, you just have to call the SNS, Seaborn library, then you generate a heat map. Then from the heat map, you can actually now pass this correlation here. So just pass this correlation. This correlation that you're seeing here, you now visualize it inside a heat map. Pass it here. So if you draw this one, draw V, you'll actually get a heat map of the same. This is actually what we call a heat map. So you're going to notice that we have a relationship between these columns and these columns here. Now to see the actual values, you just need to pass the annotations. You need to pass the annotations as true. And then you can provide the title, and then you show that graph. And this is what we call a heat map. Now you can visualize this one better. So the higher the correlation, the lower the correlation, then we get this kind of color. The higher the correlation, then we get this kind of color here. So for example, this 47 was the correlation between life expectancy and polio. Yeah. Also, negative 56 is life expectancy and HIV and AIDS. So HIV and AIDS. So the higher the rate of HIV and AIDS, the life expectancy reduces by 56%. So it's actually very easy to visualize, because if you want to see all the good negative correlation, you just have to identify this color here. I hope I'll share this piece of code. It will be very, very useful, especially in our machine learning classes. I hope I'll share that one right here. You can also try it out. So if you want to see good negative correlation, you just have to identify this color here, the black color. For example, BMI and thinness. BMI and thinness, also life expectancy and HIV. Another one is, what else? Adult mortality and life expectancy, and so on and so forth. It's a very good one. So adult mortality, it's at almost 70%. Okay, another one is life expectancy, and this one. And then if you want to see a good positive correlation, you just have to identify this color here. For example, life expectancy and BMI, and so on and so forth. So I hope this one makes sense to you. And this is actually what we normally call correlation analysis. So if you increase the size here, let me see, this is the length. And the other one is the width. So we're going to draw a very good figure like that one. So any questions so far to there? Any questions so far to there? So now we go to handling missing values. So if there is no question, I think now this is a very important aspect where we talk about how do you now start handling missing values. Then later we're going to talk about how do you handle outliers. We're going to talk about how do you remove duplicates and garbages. How do you do data encoding, and so on and so forth. So let's do that one very fast because of time. So let's start with handling missing values. Very important. Handling missing values. Handling missing values. Handling missing values. So let's go to now handling missing values. So we are trying to clean the mess that we've actually seen. So I want you to add a code cell here. Then we talk about, okay, let me first by adding, let's first start by adding a text cell. Add a text cell. So we talk about, just give it a title. Handling missing. So I think this is our step 5, according to the notes that you're using. Step 5 is now, how do you start handling missing values? So you can have the title, then you can introduce the code cell, and then now we can start together. So because of time, I will just copy these notes here, then we explain them together. Just copy these notes here. Okay, we can start by checking them. Let's check again the missing values. So let's check again. So we saw that if you check missing values, we saw that we had some of the missing values. So let me do this one. So we can just say, take our data. We call the is null function, and then we do the sum. So if you run this code, it is actually displaying that we have a lot of columns that are having inconsistent value. Now, how do you handle that one? We have several ways of doing that one. And I think that is what is being explained here. We're going to use this one to explain it. Let's copy this one. And then we test it right here. So, for you to handle a missing value, you need to choose the method of inputting that missing value. So to input is to replace it now. So there are those people who say that if you have a numerical, let me just say, this is for numerical. If you have a numerical, then let's say you're feeding people's marks, and one student is missing some marks. So if you don't want the missing marks to be empty, you can decide to fill it by the mean marks, the median marks, or I don't think the mode should be there. Okay? Yeah, I don't think the mode should be here. The mode. Yeah, you can actually decide to feed it by either the mean, the median, or the KNN inputter. So in this example, let's say the life expectancy column have 10 missing records. Let's begin there. The life expectancy column have the 10 missing records. So let's first check. Let's take the column for the life expectancy. We say this is actually how you pick a column from your data set. It's actually how you pick a column from your data set. So if you run this one, this is your life expectancy column. I hope you can see it here. It's actually a series. This is a panda series. So we are being told that this column, life expectancy, have 10 missing records. So therefore, to clean it, you will need to actually get the mean life. You can actually decide to fill the missing records by the mean life expectancy. For example, if I say dot mean here, so I'm being told that the mean life expectancy is 69. So those 10 empty records, we can actually fill them by the mean life expectancy. Or we can also decide to pick the median. So the median So the median life expectancy is 72. So it depends now with the organization policy, which is the best one to fill to the missing record. Is it the average or the most, the central value here? So I think most people realize that most of the people actually fill the empty record of a numerical column with their mean, okay? With their mean here. So how do you do this one? To do this one, we normally use, I can say we normally use the fill underscore nar function. So how do you do this one? Yeah, these are very important. That's a very good observation. Why do we need this space? Because someone was typing this column provided a space. So if you don't provide this space here, you'll get an error. This is a key error because the column that was typed was having a space. So you'll have to provide this. If you don't provide the space, then you get a key error because the column name that we have here, it is actually having a space on its own. It's only that you cannot see that one. So for you to get it right, you have to pass the exact name that was typed there with a space, like that one. I have answered down. You need to provide this space here. So that now, because the column name was typed exactly that way. Okay. And these are some of the cleaning that you can do. These are some of the cleaning that you can do, but for now, you can just work with it that way. Okay. Now, to fill these empty records, what we can do is that we can take that column again. Let's take that column, data. We take the column life expectancy, and pass this one here. This should be making sense, so that now we go very, very fast. So to fill the empty record, we normally call the fill null function. If you want to now fill the empty, we normally call the fill null function here. And then the first parameter here should be the value. The next parameter should be the commit. To commit is to ensure that the change is done, the column. This is something I'm going to demonstrate, okay? So we've said that we can either fill the value with the mean. So this was the mean life expectancy. You can just copy it here and paste it here. That one. So let's try to run and see whether we have filled the empty records. I want us to see whether the empty records have been filled. So if you run this one again, you're going to notice that still life expectancy column, we still have the 10 empty records. What is the reason for that one? So the reason for that one is that you need to commit the changes. This is the next parameter, very important aspect. If you don't commit the changes here, then this operation will not be effective on this column here. So how do you commit the changes? To commit the changes, you'll have to give it a comma. That was the first parameter where we pass the value, which was the mean, and then we say in place as true. That is actually how we commit the changes. So anytime you want to commit changes to the column, you'll have to pass this command here. In place, you give it Boolean true, meaning that we go to that particular empty record and then we fill it by the mean empty record. So if you run this one, I hope you've seen we have actually cleared all of them. Now they are zero. Some people might decide instead of the life expectancy mean, we can actually decide we go with the median like that one here, and go with the median. Yeah, so sorry for that one. So I was talking about you filling the empty record. So the first way you can fill it is either by the mean or the median, okay? So I think most people go with the mean. And that is where majority are. So you decide that all the empty record, you can fill them with the majority, the average. So you can also do the same for adult mortality. If you want to fill for adult mortality, just copying this one here, you paste it here, that one. Then you just need to pick the adult mortality column. Adult mortality. That adult mortality. Adult mortality. So you need to pass the exact column name, the way it was typed. Otherwise, you normally get a key error. So adult mortality, I think the column name was that one. Then you just need to pass it here. Like that one. So this is actually filling the adult mortality. So if you run this one, now we have 10 empty records for adult mortality. Okay. So if you run this one, we've now filled it to 0. So I hope you can see adult mortality is also 0. So you filled it with the mean. You fill it with the mean or the median. So if you decide to go with the mean, it's okay. Or you can also decide to go with the median. So similarly, you can take alcohol, you pass the mean, you run it. Now the alcohol is 0, and so on and so forth. Okay? And so on and so forth. So you're going to notice that we are actually repeating ourselves a lot. We are repeating ourselves a lot. Okay? We've repeated ourselves on the life expectancy, we've repeated ourselves on the adult mortality, on the alcohol, and so on and so forth. Okay? So we need a for loop. I hope you're together. We might need a for loop so that we can actually pass to all the empty records and then we fill them. Okay? So for example, I want to fill for hepatitis, BMI, and polio at once. So to do this one, you can actually have a for loop. You can actually have a for loop like this one here. If you don't want to repeat yourself, that is. If you don't want to repeat yourself, you can also do it in this order. I think I can copy this one. Then you can now, inside this column, this should be data. Make sure this is data. And also this is data. Data, yes. So this one will actually fill for all this one at once. So you just need to pass your columns here. So we have BMI, polio, income, resources. I think we can also take the hepatitis. Can also take the hepatitis here. Hepatitis B. The other one. There's BMI. BMI is already there. Total expenditure is already there. Okay, let me first run this one and see whether we are filling the empties. So now we're almost there. I hope you can see you're filling them. So now we're remaining with total expenditure. So I can just take this one very easily. I pass it inside the list here. I pass it inside the list here so that I can now take it inside the for loop. I take I fill it the mean, and then in place as true. So there's total expenditure. There is diphtheria. We have a total of 19 empty records. And so on and so forth. So we can also pass diphtheria. So if I run this one, there could be one key error, diphtheria. Looks like, I don't know, diphtheria was typed. So I don't know whether we have spaces or not. So let me just do away with it. It's a key error. And so on and so forth. I hope you can see this is actually how we fill empty. So you can decide, I will be filling the empties with either the mean, it should have been the mean. So if you decide to go with the mean, you can always go with the mean or the median. So if you decide to go with the mean, then you'll pick the mean for all the empty records within your data. And this should only be for numerical data. for numerical data. I think I have GDP, GDP here. GDP, I run it. So I think I would be good I share this one with you. You also try to do the same. So I had started by you knowing how to pick, getting the mean, and then using the mean, fill the empty records there. So I will share this one with you here, and also try and see whether it's working on your end. So in case you get an issue, you can always let me know. Okay, so you always just, the best way is to go with the for loop where you pass all the columns with the empty records here, and then you fill it with either the mean or the median. If you want to do it one by one so that you understand what you're trying to do, then you can actually be filling them here one by one. You pick the life expectancy column, you fill it by the mean, that one. But you're going to notice that with this method, you're going to repeat yourself a lot, which normally most people try to avoid repeating themselves on the same operation. So you're going to notice that we still have others, like schooling. Let me just add schooling here as well. Let me add schooling. Let me add schooling. We run it. Schooling is 0, so it's very easy. So now from there are those columns that you can also drop them. You can also drop them. So we can also drop them. Empty. So you can decide to, number one, fill them. So you can decide to fill them. So this was number A. You can decide to filling the missing record. Filling the missing records, where we are using the fill underscore now function. Or B, you can also decide to drop the missing record. So to do this one, you can also work with the drop underscore now function, like that one. So for example, here, I can just take the data, then I call the dot drop now, and then I pass in place as true. So the commit operation is very important. You commit that operation. So this one will actually take now the remaining one. Maybe they are irrelevant. The empties are irrelevant, so you can just drop them. I think that there was a question being asked by Gloria. Can we drop them? So if you want to drop them, then you can actually say data.drop now, then in place as true. So if you run this one, you're going to notice that we've actually dropped the other remaining empty record. And now the data is actually clean. And I hope you can see that one here. So we can either fill, especially if you're working with very sensitive data, or we can also decide to drop. So let me share this one with you. I hope you can try it out on your end. Make sure that your data is now properly cleaned and we've removed all the empty records. I hope I've answered you now. I think there was a question from Gloria. I hope I've answered that question. It's time to confirm. It was a good question, but I hope I've now answered it. So can you go over how to eliminate, yes, columns with too many null values? So if you have columns with too many null values, or you wanted to eliminate columns, so normally you can just decide to drop the nulls for those columns with too many empty values. So now if you run this code here, so you need to always run this one just to confirm it. You're going to notice that we are now working with data that doesn't have any missing value, because you've either filled them or you've also dropped them. So when we'll be doing machine learning later, we'll also be talking about something called KNN imputation method. that we'll be doing in machine learning. Okay? So we can work with mean and median imputation for numerical data. We can work with the mode imputation for categorical data. So if you have categorical data, you can replace it with the mode. Only that we don't have it here. But if you are to fill empty record for textual data, then you can work with the mode. That is something I forgot to mention. Whereby these missing values can be replaced by the most frequently occurring value. Okay. So you have the forward fill and the backward fill. So any question up to there? I hope now that is okay. We have actually learned how to fill the missing records within our data. So anytime you go to the field, collect data, and you realize that you have some empty records, I'm sure you know how to actually clean that one by either filling them or dropping them. So there's also one more operation, but we'll do it in machine learning. See that it's normally called the imputation method. Imputation method. Yeah, so that is the third way you can also do that one. But this one, you're going to do it in our machine learning classes. Machine learning classes, where we are going to see how to do the imputation method. So now from there, we also need to talk about how do you now remove outliers? Because we saw that we detected some outliers. So how do you remove them now from your data? How do you remove them from your data? So for those who want to see how imputation method works, this is actually how it works, but I think it will make much more sense if we do it in machine learning. Okay? Now there's also now outlier. How do you detect? How do you remove outliers? So that is our step 6. Very important. How do you remove outliers? So step 6. Add a text cell here. Add a text cell here. Then we can now talk about removing outliers. Removing outliers. So we said that we had said that to detect them, what we've done already. So yeah, sorry for that one. So we talked about detecting outliers. So detecting outliers, we saw that we can work with a box plot. Yeah. So now to remove them, we normally work with removing them. So removing the outliers, we are going to notice that we can work with what we call so this is actually how to visually detect outliers. So the easier way of removing outliers that I think most people use are what you call the interquartile range method. This one here. I think I want to work with this one here. I think we can work with this one here. I think it's this one here. We can work with this is what you call the winsorization method. It says a way that instead of removing them, we can replace them with the upper or lower percentile values. Okay? So let's try that one here. Let's try that one here. I think there should be a diagram. It's a diagram I want to display so that now this one should make sense. I hope you're together. So this is actually one of the hardest things to do, especially in data cleaning, You're given a scenario where you're supposed to remove outliers from your data set. Okay? Supposed to remove the outliers from your data set. So let me just remove them. Outliers. I wanted to show you a diagram. I don't know why I have gotten it perfectly here. So I think I will share the link with you so that now we use it together. I want to do it in an image tab. So this is what you want to use. Let me share this link with you. This is actually the best formula you can work with to remove outliers. Yes, we are running that code, Gianna, so that you make sure that you remove the empty records. So you need to run the code above to ensure that you actually remove all the empty records. Okay? So now, this is actually now the big question. You have outliers in your data set. How do you remove them? So the best way to remove it is what we are seeing in that diagram here. This diagram here, right? Let's try to interpret what we have in this diagram. I think it will now help us understand how outliers are removed from data variations. So in the box plot that we drew, we saw that we have the outliers from the minimum end, like for example, life expectancy. And in some other aspect, we had outliers on the maximum end, like adult mortality. So if you want to understand what I'm talking about, then you can actually see some of the box plot that we saw. This box plot here. So we have some outliers that are on the minimum end here. I hope you can see this is an outlier on the minimum end. Also, we have outliers on the maximum end. So we have two types of outliers. I think, Gianna, you can go to runtime and run all the cells. Go to runtime and run all the cells. Runtime, run all the cells. So I was talking about outliers on the maximum end, outliers on the minimum end. That is where we start. Now, to look at it clearly, there is something that we call the interquartile range. Normally, it's called the IQR. So the interquartile range is the difference between the upper percentile and the lower percentile. Let's start from there. That is what we call the IQR. So this is the median, and this is the 75 percentile, which is normally called the upper bound. Okay. And this is the 25 percentile, which is normally called the lower bound. If you get the difference between the 75 percentile with the 25 percentile, that is Q3 minus Q1, we will get what we call the IQR. I hope you can see that one. So the IQR, yeah, okay, you're welcome, Diana. I hope now you're good. So the IQR is normally the difference between the 75 percentile and the 25 percentile. Get the IQR. You get the IQR. Okay. So I hope you're together up to there. I hope you've interpreted that one. Now, if you're dealing with outliers on the minimum end, let's start from here, then definitely you will have to take the Q1. So the Q1 is the 25 percentile value. You minus, this is actually the constant, 1.5, you multiply by the IQR, the one you got here. This will give us the minimum value here that is normally drawn on the box plot here. Okay? And now you can say that any value that is lower than this minimum value is an outlier and it should be removed from the data. Okay? So it's actually taking the lower bound, Q1 is the lower bound. You actually give it an allowance, so you minus, so this lower bound you minus 1.5, which is the constant, times the IQR. So any value that is lower than this minimum value is what we call an outlier on the lower bound. Alternatively, now, sometimes you find outliers that are higher than the maximum value. So to get outliers that are here, you'll have to take Q3, which is the upper bound. Q3, which is the upper bound. Q3, you add 1.5. This is the allowance, so you need to add the allowance 1.5 times the IQR. And that is actually how we remove outliers. So we remove outliers using the percentile methods. And normally, by actually multiplying the constant 1.5 times the IQR, the interquartile range. So, I was talking about the removing outliers from your data set. So we were talking about the interquartile range method in such a way that for you to get the interquartile range, then you'll have to take the 75 percentile, you minus the 25 percentile. So it's normally Q3 minus Q1. So values on the minimum end is you have to take Q1, you minus the constant, times the IQR. Similarly, the value on the maximum end, you'll have to take the Q3, which is the 75 percentile, you multiply by 1.5 times the IQR. So we want to demonstrate this one in terms of code. We want to demonstrate this one in terms of code. And I think that's why we are here. So to demonstrate that one in terms of code, we can now start by defining a function. So let's define a function. Let's define a function. We can call it any name. We can even call it remove outlier. So this function will take a column. You will take a column. You take a column. So this function takes a column as a parameter. So you'll give it a column. You'll give it a column, which is a pandas series. So if you want to define that one, you can define it. Inside this function, I hope you can see my code here. You will need a code that takes the 25 and the 75 percentile from the column. So we start from there. I hope this one makes sense. Copy this one, and then we paste it here because of time. So what this code does is that using the NumPy, so we are using NumPy to generate the percentile method. And the percentile method, we are going to take this column. So it should be, let me just say this column. This column that is passed here, the 25 percentile of that column will be stored on this variable called Q1. The 75 percentile of that column will be stored on Q3. Now, according to our diagram here, we already have Q1, which is the 25 percentile, and we have the Q3, which is the 75 percentile, the lower bound and the upper bound. This is the median, okay? From there, I hope it still making sense. We are going to take the IQR. So I'd say that the interquartile range, it is the difference between the upper bound and the lower bound. So basically, the IQR is Q3, it's the difference between Q3 and Q1. So we get IQR. According to the diagram, IQR, the interquartile range is the difference between the Q3 and the Q1, get the interquartile range. I hope you're still together there. So we have the IQR, which is the Q3 minus Q1 from the column. Now, moving further, now we need the upper limit and the lower limit. We need the upper limit and the lower limit. So the lower limit, the lower bound, or the lower Whiscal, normally it's called the lower Whiscal, it should be, lower Whiscal is you take Q1 minus the constant 1.5 times the IQR. So this is what we're trying to do here. This is what we are doing here. This Q1, you multiply minus 1.5 times the IQR, you get the lower whisker, what is called the minimum deviation here. Okay. Similarly, the maximum one, the upper whisker, you have to take that one, and then you pass it right here. So that is actually the lower whisker and the upper whisker. So the lower whisker represents the minimum here. The upper whisker represents the maximum. And I hope you've seen we've actually applied the same formulas here. So any value that is above the lower whisker, it is an outlier on the lower bound. Any value that is above the upper whisker is an outlier on the upper bound. So therefore, this function must return let me just confirm. So this function must return the lower whisker and the upper whisker. So that is where we start from. So we return that one. So we can even give it a try. Let me run this one. So for example, if you take a column like GDP, so if you take a column like GDP, so if you say remove outliers, we take a column like, let's say life expectancy. Let's say life expectancy column. So if you run this one, we are being told that the minimum life expectancy is 40. The maximum is 47. I don't know. Yes, so I think any values that is above this one, it is on the upper bound. Any value that is below this one is on the lower bound. So you can also try a column like schooling. Okay, right. So if you run this one, we have 1.7 on the lower bound, 4.8 on the upper bound. So let me share this one with you, and then you can let me know. Let me share this one with you on the chart. I'm sharing it on the chart. Perfect. So far so good. We have the lower whisker and the upper whisker. And remember, because we have done some Python function, if you want to call a function, you have to exit the function body and then you call it here. So we have a function that can actually give us, let me show you. This function can actually provide us with, show you what we are trying to do here. It can provide us with this value. The lower whisker is this value here that was drawn by the box plot here. This is the lower whisker value, and this is the upper whisker value here. Lower whisker, upper whisker. So any value that is below this one, it is an outlier below, that is too low. Any value that is above this one is an outlier that is too high. So we need to remove them from our data. Okay. So now to remove them, we'll have to use the where condition. So for example, let me just copy this one. Let me copy this one. Just to save on time now. If you paste this piece of code here, then we can actually explain what we're trying to do. If you now paste this piece of code here, we want to check the column GDP, total expenditure. So this should be remove outliers. Just pass it here. Remove outlier, then this should be data. Make sure this is data. Data. And we're going to explain what it's actually doing. Data, here, and then finally, also we have data here, like that one here. So what you're trying to do here is that we first get the lower whiskile and the upper whiskile from these columns by taking I. So I will be starting with GDP. We take the lower whiskile, going to total expenditure, index, and so on and so forth. We can even add life expectancy column if you want to. You can also add it here. Life expectancy and so on. I think this was also having some outliers that I can also add it here. Okay, let's first work with what we have so far. Now, if you have the lower bound and the upper bound, okay, the original column that you want to visualize is actually taking the numpy dot where. So we want to pass a condition whereby the value should be less than the lower bound, or if the value is less than the lower bound, we return the lower bound. Or if the value is greater than the lower bound, we return the upper bound, like that one here. So if you run this one, we've actually now removed the outlier using this where condition here. So I think I can now show you this one. So we're actually taking the condition where the value is less than the lower bound, or the value is higher than the lower bound. Then those are the outliers that should be removed. Okay? That should be removed. Now, if you visualize the box plots again, let's see the box plots again. I don't know whether it's moving. Let me just confirm. This one. This one. So let's see whether it's moving. That one there. Show the box plots. So this should be data. Looks like it's still not hitting the bound. Yes, confirm something. So I think we'll actually check that piece of code that now we can use to now remove the outliers. To remove the outliers from the values. So I think the condition that you're passing is not right, so it's not removing them. But I think I can now share this one with you. So now then you're going to check. After getting the lower bound and the upper bound from the column that are numeric, from all the columns that are numeric, we need to pass a condition that actually, let me first share this one. We'll pick all the numeric columns that we have. Then we check where yes, I think we're going to confirm because it looks like it's still not removing. Using that function, we're going to actually confirm why it's still not picking the outlier. So I think there will be an issue with the function that we have here. So okay, I think we can even work with the GPT. Then we can pass it here. Then we can paste it here. Then we can say any possible logical error. Because I can actually clearly see that, yeah, so it's having a logical error. So maybe we can check it out here. Probably the function that we are passing was not okay. So we're being told that we can actually work with the clip to cap values between the lower bound and the upper bound. So I think this should, let's see whether this should work. We can actually work with the clip function. Just a minute to confirm whether they should work. This one, the all of it. And just comment this one. You're going to check what could be the possible reason for that one. And then let's try this one here, whereby we take all the columns that are numeric, we take the lower bound and the upper bound from this function, then we clip the lower bound and the upper bound, then you draw the box plot. So looks like it's still not counting. So I think I'm going to confirm what could be the possible issue with this code. Yeah, so we are going to check on that one. Then I'll share the correct formatted code, I think, later because of time. Looks like even this one is not right. So we want to see the right function that if we pass here, it will only pick values that are in between the lower bound and the upper bound. So let's first go with this one for now. Then we are going to check any issue that we have here. Now, because of time, I don't think we'll have time to actually go through this code and rectify everything. So moving further with this one was how do you actually remove duplicates? So in case you want to remove duplicates from your variable, we see the duplicates that we had, we didn't have any, it was 0. But in case you have duplicates within your data, then normally you just have to call the drop duplicate function, and then you pass this commit command. Whereby you take your data, you drop the duplicates, and then you pass in place as true. Very, very important, especially when you have duplicate data within your data set. And then now finally, encoding data. So the encoding data is a process where we want to convert object data types into numerical data types for machine learning techniques. So if you go to the notes here, so I've talked about duplicates. We'll be talking about normalization later, but label encoding is actually a process when converting categorical variables into numerical format. This is important for algorithms that only work with numbers. So because later we'll be doing machine learning, you're going to notice that machine learning cannot process any data that is text. So for example, you have data like Kenya, you can encode it to 0. This is what we'll be calling the label encoding. If you have any categorical data, you give it a numerical value. Uganda, you can assign it 1. Tanzania, you can assign it 2. Okay? Now, one-hot encoding is whereby we want to convert categorical variable into binary column. For example, Kenya, Uganda, Tanzania can become 3 columns. So Kenya is the first one, Uganda is the second one, Tanzania is the third one. So it's what we call the one-hot encoding. I'm sure we're going to meet them in our machine learning classes. Basically, when you want to convert categorical variables into numerical variables. So one-hot encoding, you're going to see that it is very, very suitable for nominal data, where we only have the names. Very suitable for nominal data, while label encoding is normally very suitable for ordinal data, where categories have some order, like undergraduate, diploma, certificate. Also, there's some kind of an order. So we can actually work with the label encoding. When you only want to work with the nominal data, then you normally work with the one-hot encoding. This is very necessary for machine learning models that require numerical data. Okay? Then it avoids bias model where numerical label could be misinterpreted as ranking. Yeah, so to do this one, I think the label encoding were done here. So for example, we have, so this was for label encoding. I think in our data here, we didn't have the correct format. Okay, just a minute. Yeah. I don't think I can run this one. Let me just do it here. Let me just do it here. Let me finalize this class. So let's just do it here. So we are now talking about encoding. Encoding. So you've seen that encoding is the process of converting categorical columns into numerical columns, or you can call them numerical labels. Yes, that is what we call encoding. It is very important, especially for someone doing machine learning, because you're going to notice that machine learning algorithms are designed to work with numerical data. So anytime you have a categorical data, then you have to convert them to numerical label. So a good example is, let's have a column like status. So if you have we normally, so you can actually say that we normally call the group by function. So there's a function called group by in categorical columns. Categorical columns. So for example, you are doing machine learning. And for example, in our data here, we have a column called status. So you can actually say data dot group by. Then inside this group by, we pass the categorical data like status. Sorry, let me type it very well, status. And then We can run it here. Then from here, we can now get the size. That's not size, sorry, size. So with group by function, you're going to see that status have two categories. We only have developed, which actually contributes to 416 records, and developing, which contributes to 1830 records. So these are the two values that we have in status. So we've actually grouped them by their size. So if you say country, this should be very long. Say country, we have a total of, so these are the countries. We have a total of 143 countries here, like each contributing to 16. So we have of Afghanistan 16, Albania 16, and so on and so forth. So maybe now you want to convert these names to their corresponding labels. So I think because of time, we can work with status. We can work with status in such a way that we say that, so this one, you can actually view it in this order. Sometimes you can actually plot, and then you say the kind is bar. Let's go with the pie chart. Okay. So if you run this piece of code, then you are going to see that we only have two categories of status. We have the developed. Let me even actually pass. So the auto page as I just want to share this code with you, then you can actually work with 1.2 plot 2%. So these are our two categories for the status. So this is normally when you are dealing with categorical data. So you can actually decide to remove that one. Just remove this one here. Or make sure you've typed the thinness very well here. This is not, ensure you've typed it very well. It looks like this. You had some issues here. So make sure you've typed it very well. Remove this aspect here. Ensure that you've typed it correctly this way. So now I'm talking about categorical data. I'm talking about categorical data here. So we have two categories of status of the countries. We have 18% that represents the developed countries, and we have 81% that represents the developing countries in our life expectancy dataset. Now with label encoding, we normally say that this is a label developed, which is categorical. It's a text data. Similarly, developing is also categorical. So in machine learning, you cannot work with categorical data here. You will need to label and code them in such a way that if you meet the name developed, you actually encode it with a number. I can give one 0, then this one I can give it 1. I can maybe give one this, I can provide this one 1, then this one 2. That is what we call the label encoding. So to do label encoding very fast, so that we finalize. So label encoding, we actually work with we normally work with the replace function. So you want to replace the developed categorical name to a numerical data. So we normally work with the replace data. So to do this one, we can actually take data, then we pick the column. The column is status, so it's actually status, this one here. So that is the column that you want to label and code. I hope you're good. Like that one. So this is the column that you want. The column that you want. So you have developing and you also have developed. 18% we have is for the developed, 81% we have is for the developing. So to label and code this one, we just have to call the replace. We'll actually have to call the replace function like that one. Okay. And this function takes two items. I want us to begin here because it's very important, especially in machine learning. The first item that it takes here, it's actually a dictionary where we provide key and value. So it normally takes a dictionary where we give key and value. We say dictionary provides key and value, and then comma, we actually provide the commit operation as usual. We commit that operation. So we take a dictionary where we'll be providing key and value, then give a comma, and then we actually say in place as true. And this is actually how we do label and coding. So we'll have to do the commit. Now, inside this dictionary, I hope you're there. Inside this dictionary, we'll have to give the key and the values, where we are saying that, so I've actually pressed enter, where we are saying that if you meet the name, so there is a label called developed, you will label and code it, let's say 1, or you can give it any value. If you meet the name developed, give it 1. If you meet the name developing, provide it with 0. So this is the key. So the key is the existing name. The value is what you want to label and code it with. Similarly, if you meet developing, you'll actually assign it a corresponding numerical value. So if you run this one, and now you check your column again. So let's do the group by again. Let's do the group by here and confirm whether we have labeled and code. So just take data, we group by, the column name is status. I don't want to plot, just want to see. And then we get the size like that one. And basically, this is what we'll be doing, and this is what we'll be calling label and coding. I hope we can see that initially, this 0 represents the developing countries. So the name was developing country. We have a label and coded with 0. Then 1 represents the developed country. So this is actually how we do that one. We actually call the replace function. We pass a dictionary here, then we pass the in place as true. So inside that dictionary, the key should be the existing value, for example, developed or developing, and the value should be what you want to do the encoding with. So I think this should be giving us now a very solid foundation for those people who will be going direct to machine learning, and also for those now who will be doing data analysis using aspects like Excel. And that is actually what we call label encoding. So you want to assign a categorical data a numerical value here. So this categorical value, give it a numerical value. Similar to this one, we encode it. This is what we call label encoding. So any questions so far, so good up to there? Any questions so far, so good up to there? So now from tomorrow, we'll be working on case study projects. We'll be working with case study projects in such a way that now we can be working on analyzing a real world data. So I'll be picking a certain data, like for example, we pick a supermarket data, we do an analysis for that one. We pick a financial data, we do an analysis for that one, and so on and so forth. That is starting from tomorrow. So if you have any question, now I can actually have a look at them. Somehow, yes, somehow, especially the one we've done for the interquartile range. But the good thing is that all these mathematical functions, we are generating them from functions. Yeah, but we say that mathematics is one requirement in data science, but it's not that much. It's not that much. It's not that much. So any question? So I think, Gian, I don't know whether you had actually fixed this error. So you have two ways of fixing this error. One, either you remove the column that is giving you an issue, this column called thinness 0 to 19 years. You can remove it here, this column here, or you can make sure you type it properly. Make sure you type it properly. Thinness 1 to 19 years. Make sure you remove this. I think these were some errors that you had. This /, this X, and this A. Make sure you remove them. Then I think it should work perfectly fine. Any other question up to there? So now I feel like we have actually done all the requirements we needed for someone to be a data scientist or a data analyst. The first one is getting data from the source and now being able to process that data. So now from there, tomorrow, we are now going direct to doing some analysis so that now you're able to understand how you can do now an analysis for a real world data. For example, you have medical data, you have finance data, you have marketing data. How do you generate those kind of insight? So the first thing you have realized is that you must work with a properly clean data. So if you're not good with data cleaning, then this is the role for a data engineer. So someone who is very good on fetching data from the source and then pre-processing that data so that it's ready for analysis. So if you're someone who had some inspiration to be a data engineer, then this is your role. You get data from the source, and then you do the data pre-processing by doing the sanity checks. I think I mentioned them. You read the data, you do sanity checks, you explore the data, you handle the missing values, you remove outliers, you remove the duplicates, you do what you call normalization, label data encoding, and so on and so forth. Now from here, you can now hand over a clean data to now for analysis or machine learning, okay? So this one ensures that the data is structured, the data is accurate and ready for further analysis. So by actually removing all this missing value, removing outliers, duplicate, normalizing, and encoding categorical variables, we will actually create a data set that provides meaningful insight and improve the performance of our machine learning models that you want to see now more. So without any question, we confirm whether there is any other question. Without any other question, as I can see, I basically wish to stop there for today. And then now we meet tomorrow. It should be very interesting where we now analyze data for a particular field. So I'll be sharing all these code examples with you so that now you're able to pick data from any source and then perform an analysis. Now, after doing this kind of analysis, we are going to transition because I've been getting this question from a lot of students. We are going to transition either for those students who are doing data analysis or those students who are doing data science. So if you're doing data science from here, we are going to do machine learning. So that is where we are going to start for students who are doing data science. For students who are doing data analysis, we're going to start from understanding Microsoft Excel. We're going to start from there. Then we move to Microsoft Power BI. Then you talk about SQL. That is for someone doing data analysis. Because like I had mentioned earlier, data analysis mainly focuses with the tools that we have. On the other hand, data scientists, mainly they focus with predictions. Yeah, it will be possible because will be having pre-recorded lessons. So it will be very, very much possible for you to do both data science and data analytics. So long as you've enrolled for both courses, I'm sure you'll be able to do both of the two courses because both of them, they are very, very useful in the industry currently. So it will be very, very possible in such a way that we'll be providing pre-recorded sessions for both data science students and data analysis students. So I'm sure this was a very lengthy class. I wanted at least we finish this lesson today so that now tomorrow we transition to analysis part. The analysis part, like we had mentioned for this program, if you check on the outline, we had mentioned that we needed to learn pandas, numpy, matplotlib on week 1. So on week 2, you needed to know how to do data visualization. Then now in our 3rd week here, we need to do some end-to-end projects, okay? So for example, you can do customer behavior analysis. So at the end of the day, your insights should be telling us the behavior of customers in different businesses. For example, e-commerce, shops, or retail stores. You can analyze climate change data in such a way that your analysis should be giving us the temperature and the carbon trends within the Earth. You can decide to do financial data exploration. So you can be providing us with the insights to do with the stock market trends and investment insights that can be used for decision making and also health. So this is actually what we'll be starting to do from tomorrow. And I'm sure they are very, very interesting. And they now give us a good foundation to transition either to data science or data analytics. So without any other question, which I can see there's no any other question, let's stop there for today. We start tomorrow with our analysis. So have a good day and bye-bye.